Okay, so we're in this chapter of solutions, and so today what our focus is going to be is one of our signs of a chemical change. So as you remember, our different signs of a chemical change that we had were things like color change, change in temperature, or a light given off, so endoexothermic bubbles, which meant that a gas was being released, or a precipitate. And so our focus today is going to be on this last sign of a chemical change, which is a precipitate. Okay, so a precipitate is something where you have a new solid that's formed.
The solution here of silver nitrate is similar to that ion-rich water that seeped through the Montana limestone millions of years ago, and we can use it right here at this desk to recreate the ancient reactions that deposited silver in veins across our landscape. But instead of the types of salts found in limestone, we can use a very similar and substantially more familiar ionic compound, table salt, good old NaCl. Add some drops of sodium chloride, also known as your salt water, to the silver nitrate solution, and there you see your precipitate.
So let's kind of look again at what he just showed us, that little example that he had. And so what we had is we had sodium chloride, and it was aqueous. All right, so we already learned about these states of matter. And so the aqueous things are the things that where you take a solute, right? So the little solids, we put it into some water and we mix it around, and we now have if this was a blue, we would now have this blue liquid. This is a solution, right? A homogeneous mixture. This solution we represent with the state of matter aqueous. All right. All right. So if I have sodium chloride, and then he also added in the other liquid, which is silver nitrate. Okay. So we're going to label that with another little aqueous over here. Okay. And we wanted to know what the products were. Okay, and he kind of told you what they were just a second ago. But let's kind of look at this part, because you got to be able to recognize what type of reaction this is first. So looking here, we see that we have some sort of a compound, some sort of another compound. So this is the one where it was double date gone wrong, which means everybody kind of switches partners. So this is what you can memorize for this whole section of this chapter, is it's always talking about a double replacement. That's what we're focused on, is we're taking two different solutions, indicated here with aqueous. You can see that they're compound. We're putting them together, which tells us that it's going to be that double replacement. So therefore, our products are going to be switching either the first thing listed or the second thing listed. So I always like to switch the first thing listed. So I'm just going to switch out my sodium and my silver right here. So when I go to write these products, we're going to keep it simple. We're going to say, okay, instead of it being sodium, it's now going to be silver with chlorine behind it. Okay, so here's my continuous arrow. Okay, sodium with chlorine behind it. We're going to leave a little space for states of matter, plus, and then I'm going to have now my sodium is going to be over here, and it's going to be connected to that nitrate. Now that we've done that, now we have to analyze what we've got and figure out which ones are soluble and insoluble. So just like Hank said, soluble, we are going to be putting the aqueous with it, means it dissolved in water. So it dissolved within itself, and you're not going to see anything because it's just going to be a liquid. But the insoluble, we're going to be putting solid, and this right here will be your precipitate. Okay, so I want to kind of model what we're about to look at right now. Okay, so we're going to look for basically, as you notice, looking down this whole list, these are mostly your anions, like he said. So anions are the negatively charged things. Those are the things that are listed second. Okay, so you're going to use that. The only exception to that, by the way, and we'll see this in one of our examples, is this ammonium ion, which is a cation, and so that one happens to show up. It has its own rules as well. Okay, so what we're going to do is we're going to look for our anion on this list. All right, so search down the list. We're going to find chlorine. There it is, right there, right here. Chlorine is soluble, is aqueous, unless, then we're going to look across, it says compounds of Ag, Pb, and Hg. So this one is silver, lead, and mercury. All right, cool. So basically we're saying if it has one of these three compounds, then it is no longer going to be that aqueous that we just said. So chlorine is aqueous unless it has one of those. Well, there you go. Ding, ding, ding. It has silver. So that means it just turned into solid. So what you would do on your end, after you have the whole reaction written out, you would go back to this, and now we're going to put in our states of matter. So this one is our solid. Okay, this sodium nitrate, we're going to, once again, look at our anions. We're going to find it down here on the list. Here's our anion up here, and we're going to say the sentence together. So nitrate is aqueous, right? So nitrate is soluble or aqueous unless, and we're going to look across, there are no exceptions. So that means no matter what, nitrates are aqueous, which is something that Hank also said in that little video clip. All right, so start with that.